Hello students, my name is Shesi George, your professional accounting teacher. Please, before you continue with this video, try to subscribe to my YouTube channel. Okay, in this video we are looking at the concept of presentation of data. Precisely, we are looking at Ogive, or a cumulative frequency curve, which is one of the components of presentation of data. All right, so let's get started. What is an Ogive? An Ogive is nothing but a graph of cumulative frequencies against class boundaries. An Ogive is also called a cumulative frequency curve. A cumulative frequency curve. Okay? It is a graph of cumulative frequency against the class boundaries. All right? So I'm going to use this question 4 to demonstrate the concept of an Ogive. All right, you have been given the frequency table below, shows the time taken for 80 people to travel to an event. You have been given the time interval and this, then you have to construct a cumulative frequency curve for the distribution. Then you have to estimate the median, the semi-interquartile range, and the 75 percentile from the curve. All right, so let's get started. Okay. You start by writing the time interval and which you are giving. You will copy the time interval. Okay, we have 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, 45 to 49, and lastly 50 to 54. Then you take the class boundary. The class boundary is the halfway mark. So what is the class boundary? The lower class boundary here is 19.5. You remove 0.5 from this. Okay? Then you add 0.5 to this, to 24.5. 24.5. You remove 0.5 from here, then you add 0.5 to this. That is 29.5. Then 29.5, you add 0.5 to that, 34.5. 34.5 to 39.5. 39.5 to 44.5. 44.5 to 49.5, and 49.5 to 54.5. Then you copy the frequency. Okay, the frequency has been given. Then you have 3, 8, 17, 29, 15, 16, and 2. Then you take the cumulative frequency. You calculate the cumulative frequency. We start with 3, then you add to 8. 3 plus 8, we give 11. 11 plus 17, we give 28. 28 plus 29. So what is 28 plus 29? I think that is 57. 57 plus 15. 57 plus 15, we give you 72. 72 plus 6, of course, we give you 78. 78 plus 2 will give you 80. Don't forget, your last cumulative for this data must be 80, because we have 80 people. Okay, then you will repeat the class boundaries. Okay, all right, the upper class boundaries. Here we have 25, 24.5, 29.5, 34.5, 39.5, 44.5, 49.5, and 54.5. Okay, now the next thing is to construct your Ogive in a graph. Don't forget. So for the graph, you have from the origin of the graph, this is 2 centimeter. You count 10 boxes. Okay, if you look at the y axis, the y axis, It has been scaled to 2 centimeters. You count 10 boxes, like I said, that is to 10 units. That is, you count 10 boxes, that's 2 centimeters to 10 units. So it must be drawn to scale. Then on your y-axis, we have the class boundaries. The class boundaries. We have the class boundaries. Then here we have the cumulative frequency, okay, on the x-axis. On the y-axis. So here you now repeat okay, this on the on the x-axis. You repeat the class boundaries. You repeat, so as follows. Look at what I'm going to do. You will start with the lower class boundary of the first class. All right, start with this, then you come this way. You start with this, you come this way, okay? You start with this and come this way. In this format, look at, you have 19.5, then we have 24, okay? So if you look at this, 24.5, you repeat all this. So we have 24.5, you have 29.5, we have 34.5, we have 34.5, 44. So this is 39.5 and 44.5, and this is 49.5, and here the last one is 54.5. okay. Then having done this, you now the first class. All right, don't forget that a cumulative an ogive is a graph of cumulative against the class boundaries, So if that is the case, you start from here, then you against the cumulative. So what is the first cumulative, which is 3? So let's trace our 3. We have, you count 3 boxes upwards, 1, 2, and 3. Okay. Then the next cumulative is 11. So you count from 10. So count a box. That is, the next cumulative is 28. So this is 28. And this is 30. Just count 2 boxes down. This should be 29. That's 28. All right. Then the next is 57. Okay. You go to where you have 60. You count 7 from 50. 1, 2, 3, 4, 5, 6, and 7. All right, class. Then you have 72. You go to 72 and count 2 upwards against the cumulative. Don't forget, class boundary against the cumulative. Count 2 boxes up. 1, 2. Okay. Then the next one is the last one is 78. So you count 8 boxes upwards. 1, 2, 3, 4, 5, 6, 7, 8. So you have to be very careful. Then the last one, of course, is 80 exactly on this line. This is 80. Then you will join this line carefully. You join all these points. Join these points. If you have a French curve, you join, and join. Okay, you join to this. All right. So this is known as an ogive. So that's your ogive showing showing the time taken by 80 people that travel to an event. So that is the heading of your Ogive. An Ogive showing the time taken, so it must have an heading. Now, the B parts, look at the B parts of the question. The B part says estimate the median. And the median is one of the measures of location which can be calculated on the Ogive. Okay, it's very common. It's a very common question. So to calculate the median, you will determine the median position using this formula. You have the median position formula. The median position formula is summation F all over 2. And here, this is our summation F. When you add all this, it must give you 80. That is the half of the cumulative. So the half of the cumulative frequency, which is 80 all over 2, and that will give you, so it's in the 40th position. So from the graph, you now write from the graph. How do you locate the median from the graph? I'm going to show you. So from the graph, the median, so you now go to your graph, is from the graph, the median is, so you go to the graph, okay, this is cumulative, that is the 40th position. You go to the cumulative frequency and locate 40. So this is where 40 is. Then you pick up your ruler. I will always advise you make use of transparent ruler, okay, then you trace this, and when it touches this, then you trace down, class. You trace down. Be very careful. Just trace down. Make sure you have a very straight line. All right. Make sure you have a very straight line. Then you trace down, class. Trace down. So this is the median. You can now read. So don't forget, we have from the class boundaries, this is 33. So just count how many boxes. So we have 1, 2, 3. Okay, 1, 2, 3. Now, if you look at the class interval, we are having a class interval of 5. The class interval is 5. Don't forget. It means then we have 10 boxes here. 10 boxes within the interval here. It therefore means that 10 boxes are to be shared by 5 units. Okay, so it means that a unit, we have how many boxes, class? That is 10 divided by 5, which is 2. So 10 divided by 5. So we are having 2 boxes that will make 1. 2 boxes, so we have 1, 2, 1, 1, 2, 2. So when you now add the 2 to 34, so we have 34 plus 2. So what is 34 plus 2? 34 plus 2 will give you 36.5. Okay, all right. So here is 36.5. So that is the median. So this is the median from the graph. So from the graph is estimated to be 36.5. All right. So that is the median from the graph. Okay. Then that is answered. Then the next question is to calculate the semi-interquartile range and the 75 percentile from the curve. So let's look at the semi-interquartile range. Okay, quartiles deals with partitioning the data into 4 equal parts. All right, into 4 equal parts. So, all right, then for semi-interquartile range, the formula for it. So you first write the formula: semi-interquartile range. Interquartile range. I'm still going to do a video on this, but how to assess, how to estimate this from an Ogive. That's what I'm doing now. It's giving us Q3 minus Q1 all over 2. That is, you find the average of Q3, where the Q3 position, so our Q3 position formula, Q3 position formula will be 3 all over 4 multiplied by summation of F. Okay, 3 over 4 multiplied by summation of F. Okay, and it is known as the upper quartile. That's what we call the upper quartile. Okay, the upper quartile. All right. So what is Q3? The position formula will be 3 all over 4 multiplied by 80 over 1, and that will give you 20. Okay, that's 60. So that's the 60th position. Okay, the 60th. All right. So then for Q1, that's the lower quartile, Q1 position formula. The Q1 position formula is nothing but 1 over 4 multiplied by summation of F, and that is nothing but 1 over 4 times 80 over 1. All right, 1 over 4 times 80 over 1, and that will give you the 20th position. Okay, so from the graph we need to locate now Q3. Take note, Q3 minus Q1 is called interquartile range. It's known as interquartile. Don't forget, I'm still going to do a video on this interquartile range. Interquartile range. So from the graph now, you now have from the graph. From the graph, you need to locate the 60th position, the way you have done for the median. So we need to locate the 60th position from the graph. From the graph, Q3 will be equal to, is estimated. It's estimated as, so you go to the graph and go to 60. So what do you have here? You go to 60. This is where you have your 60. This is your 60. Okay. Then you locate, you want to locate the, then it must touches. So when you rule a line and it touches to touch this, then you rule down, you trace it down. So let us trace down. Alright. So this is your Q1. So this is your Q3. So this is your Q3. So let's look at what it reads. Now this is it. Then I told you 2 boxes takes what? 2 boxes. So this from here is 39.5. So let's count how many boxes. We have 1, 2 boxes. So it's 1. So when you add 1 to this, that is 39.5 plus 1. So plus 1 will give us 40.5. So 40.5. The Q3 is 40.5 from the graph. All right. Now let's locate from the graph. You write from the graph. The Q1 is also, so you go to the graph. You have told the examiner that from the graph. So that is 20. All right. The 20th position. Look at the 20th position. So you go to 20th position. From the cumulative frequency, that's 20, and this is 20. It must, once it touches the Ogive, then you trace down. You trace down. Then let's calculate that. Right. How many boxes are here? 1, 2. That is 1. 1, 2, 2. 1, 2, 3. So you now add 3 to this. So when you add 3, that's 29.5 plus 3, and that will give you 32.5. So here we have 32.5. Okay, 32.5. So So from the graph, our Q3 is 32.5. Our Q3 is 32.5. So you can now calculate your semi-interquartile range. You now say therefore our semi-interquartile range is 40.5 plus 32.5 divided by 2. So what do you have? 40 plus this divided by 2 from your calculator. 40.5 plus 32.5, and that is 73. 32. Minus. This is minus. That's silly of me. That is 40.5 minus 32.5 minus. Okay, and that is 8. So that will give us 8 all over 2, and that is 4. So that is semi-interquartile range is 4. Semi-interquartile range is 4. Okay. Now, lastly, for this question, we have to estimate the 75 percentile. So the 75 percentile, that is B1, 75 percentile will be percentile. Percentile is given as 75 over 100 times 80 over 1, and that will give you 60. So the 75 percentile position. The position formula for this is also the percentage. If the 75 all over 100 multiplied by summation of F. So take note of this formula. So it's the same thing with the third quartile. And what do you get as the third quartile? So the third quartile, I think we got 40. Where's the third quartile from the graph? We got 40.5. Okay, it's the same thing. Are you with me? The third quartile, that's the upper quartile. The upper quartile. So 75 percentile is the same thing. So from the graph, so you don't need to go to the graph again. From the graph, the 75th percentile, the 75th percentile is 40.5, and that ends the question. All right. So you look at the graph. You can pause your video to look at the graph. All right. So if you love this video, please do share with your friends. And don't forget to subscribe to my YouTube channel. I remain your lecturer, Shesi George. Thanks for watching. Bye for now.